Welcome to this concluding session on Industry 4.0. Generally, we have been discussing a lot of applications of artificial intelligence, machine learning, particularly in manufacturing, but we have looked at other industries also. So this session is kind of summary of some of the industry trends and future applications of AI, particularly in manufacturing, but of course, we will look at other industries also. So we have been discussing about digitalization, right, and digital transformation, and Industry 4.0, and so on. So let us go from Industry 3.0, right? The Industry 3.0 started with computerization, all the CAD, CAM, right, CIM, and all that, right? So that was the first start of getting analog data into digital format, right? Then we got into internet, and therefore connectivity, and therefore data started moving from one machine to the other machine. The place where the data is generated, there may be other place where the data can get analyzed, and so on. Internet helped in that sense, right? So essentially, what was the whole benefit because of this? We had analog data we were analyzing. The capability to analyze analog data was limited because we couldn't use compute on that, right? So we were doing only manual computations. Once the data became digital, right, we started analyzing data in a slightly bigger way, right? The first benefit that happened was essentially visibility. We got to know what is happening, right? So earlier we knew, right, even before we started getting data in the digital format, we definitely knew what was happening. But the first benefit of digitalization, and therefore digital data, was essentially understanding. First of all, seeing what is happening, visibility. We got a lot of visibility. Then the next phase came, saying that why was it happening, right? So the root cause analysis. So the trend analysis, what is the underlying reasons that I'm getting this kind of performance, I'm getting these kind of failures, I'm getting this kind of quality, I'm getting this kind of supply chain risks, I am getting this kind of profits, right? So we started understanding our businesses better with the use of data, right? From the data, we started getting more juice out of it, right? First of all, only understanding what is happening, then going to why is it happening, right? Next, we started building predictive models, and that gave us the power of understanding what is going to happen next, right? What will happen. So from understanding of what is happening in the organization right now to a capability that told us what will happen in future, right? So that started getting built into our systems because of digitalization, because of Industry 4.0, because of various hardware and software that we started building. And therefore, where are we heading now? We understand what is happening, we understand why is it happening, we can predict with certain accuracy what is going to happen. So next obvious extension of this is then, if we know what is going to happen, why should the machine wait for a human intervention to say that, well, please press this button so that the damages are reduced, or please press this button so that the performance is increased. If the machine already knows what is going to happen, if the machine already knows why is it happening, why can't machine take its own decision, right? So essentially autonomous decision making is now possible because of all the small steps that we have taken in the right direction, right? And that will be getting the maximum value out of this whole digitalization trend, right? So those are the generally accepted benefits of first of all, digitalization, getting more data. Once we have data, we can start building algorithms that can use this data, and depending on the sophistication of the algorithms, we can actually get more value for our data, right? What are the main application areas that we started using the AI techniques or Industry 4.0? The first thing that we need to understand is, right, in the last 15 odd years, a price of a typical sensor, right? We have spoken about sensorization. Price of a typical sensor, the most basic sensor, in the last 15 years has gone down considerably, right? Roughly speaking, a sensor that used to cost us approximately close to about $2 is now costing us roughly about 40 cents, right? Prices have slashed considerably. There is a essentially there is a thinking that roughly, right, roughly we are talking about something like something like 150,000 robots, collaborative robots, is the projected sales, right? Is the projected sales. Roughly, we are talking about roughly about 36 billion devices being connected, right? IoT connections, right? So those are the kind of trends. IoT industry is expected to be about 15 trillion in terms of global GDP, right? That is the trend for 2030, right? Essentially, because of all this, because of sensorization, right, because of connected devices, we are going to have more network of data, giving us even better understanding and even better trend prediction, right? Even better trend prediction. So, roughly speaking, where are we actually using these AI algorithms? Roughly, first of all was maintenance, right? Why was maintenance the first target? Because I have put sensors, I have put sensor on the machine, and this sensor is giving me a lot of data. And once I understand the data from the sensor about the machine, I can actually then say that I can predict the behavior of the machine. Once I understand the breakdown, I can understand the performance of the machine, and therefore I am going to maintain the machine better. Predictive maintenance, right? So we are roughly looking at somewhere between 20 to 40% reduction in maintenance cost because we are using these sophisticated predictive maintenance algorithms that are driven by data, right? Therefore, because of better maintenance, we are thinking of minimum about 30% cost reduction because of machine breakdowns, right? Machine downtime. Nobody wants their machine to be down, right? Nobody wants their assets to be not delivering, right? So so those are some of the predicted trends because of implementation of various digital technologies, AI ML being definitely at the forefront, right? We spoke about inventory optimization using data, and we looked at that RL algorithm, right? Inventory is one place where a lot of cost reduction potential is possible. So it is estimated that because of these algorithms that now are getting utilized across the industry, roughly about 20 to 40% reduction in inventory cost, inventory holding cost, inventory transportation cost, inventory carrying cost, right? So we are expecting a good amount of cost reduction because we are managing our inventory better, right? There are two ways of managing inventory in the supply chain, trying to reduce the cost of inventory in the supply chain. First of all is to carry less inventory, right? Carry less inventory, and that's where inventory optimization is going to help us. But inventory is also needed because it kind of absorbs the shocks in the demand. You need inventory so that if the demand goes up suddenly, I can still meet the demand, right? So therefore you can't go to a stage where you carry zero inventory. So there has to be that optimal level of inventory. So one way to reduce inventory cost is to plain say that I will carry less inventory in the supply chain. Second way to reduce the inventory cost is to say that I will reduce the spoilage, right? I will reduce the wastages. I will reduce the obsolescence. If the product is sitting in the warehouse for really long time, and it sits in the warehouse so long that it becomes obsolete, right? What's the point of keeping the mobile phone in the warehouse so that with a hope that it will sell, and then before that product goes out of the warehouse and gets sold, I have new version of this product released, right? After the new version of the product release, the demand for the earlier version is going to come down, right? So can we avoid this? And obviously we are able to avoid that, first of all because we are managing our inventory better. Also because all these algorithms, data algorithms are getting used in design itself. We spoke about that during the course. So we are looking at something like 25-30% reduction in the time to get to the market, right? So the product design stage itself has shrunk considerably, right? So there we are, since the product is coming to the market. Another place where we have done considerably well is in our forecasting algorithms, right? Our forecasting accuracy has definitely gone up significantly, right? We are not even talking about 20-30% improvement in the forecasting accuracy. We are talking like more than 70% increase, right? I mean, we are very good. We are able to predict the demand better. We are able to understand who is going to need what and when, right? So all these things are definitely better understood, right? So all that is going to give us lot of benefits, right? Lot of benefits. So generally speaking, right? Generally speaking, it is predicted that by around 2035, the gross value added to the industry because of AI, right, is going to be significant, right? For example, I'm just looking at the survey that is available here. So for example, manufacturing industry, right? Obviously the growth is predicted. Every industry is going to grow, but some industries are going to grow slower, some industries are going to grow faster. So there is some baseline growth that is going to happen, but people have been able to project the impact of AI on these particular industries. So without manufacturing, it is expected, without AI, manufacturing industry is expected to grow roughly about 2.3% in terms of gross value added up to 2035. But with the help of AI, the potential for manufacturing industry to grow actually increases to about 4.5, right? So almost double. So impact of AI on manufacturing is significant, right? Similarly for agriculture and forestry and fishing, right? Applications of AI are going to provide a tremendous growth in terms of gross value added, right? Where are potentially what are the areas where AI is helping specifically? First and foremost, it's uncertainty modeling, right? There is uncertainty everywhere across the supply chain, across manufacturing processes, everywhere, right? Uncertainty is really the main hurdle. As we discussed earlier, uncertainty can be handled by AI with better forecasting, right? Real-time tracking, autonomous decision making process. So therefore there is no lag in the decision making, right? To large extent we can never remove uncertainty, but certainly we can control uncertainty to a great extent, and that is what is going to drive this entire gross value added increase because of supply chain, right? Because of supply chain. Now there are certain industries which are definitely doing better. For example, financial services industry, financial insurance, that kind of industry. They have always been data savvy, and therefore they have been doing quite a lot on using data, right? Quite a lot on using data. So the other industries, for example, information communications, right? Construction industry, well, not they are not doing that great in terms of implementing AI, but they are expected to catch up very soon, right? I'm looking at various of these surveys, and I will put up a link for these surveys at the end of the lecture, right? But essentially these are what is driving these industries are essentially driving the acceptability of AI across the board, right? Where is the gross value added going to be significant? Gross value added is going to be significant because of automation. We are going to go big way in terms of automation, right? So it is expected that of the total value added, two major factors, right? This whole data-driven algorithms, and because of data-driven algorithms, automation. These are the two major drivers in increasing the gross value added in particularly manufacturing sector, right? We are going to do much better in terms of meeting customer requirements because of using data. We are able to do real-time product customization, right? Real-time product customization. Our responsiveness in the supply chain has definitely gone up because of the visibility, right? Because of the visibility. So many things are now better understood quickly, so that the managers or even autonomous algorithms can take decisions much faster, right? Let us quickly focus about 10 more minutes to focus on what is happening in Indian industry, right? Indian industry. What I spoke to you so far were global trends. So what is happening in industry, right? Most of the industry leaders have very easily accepted cloud usage, right? Everybody saying that yes, they are committed to cloud. Both at the industry level or as well as at the organization level, everybody accepts that the cloud usage has gone up. Robotics were always famous in manufacturing, right? Nobody had to be told that robotics are important. We were using robotics in the assembly line. We spoke about example of robots painting the car and so on. So those were always high, and they are expected to become higher. But now robots are going to become smarter, right? They are going to become more collaborative. It's not a dumb machine that you had to program earlier and then it cannot respond. It is going to be able to be responsive. And once again, even the Indian managers now agree that robotics use is going to grow in industry as well as in their own organization, right? Really, I mean, nobody can say that they are not using data science, AI, and big data, so to say, right? Everybody has caught on to the wonderful applications of data, big data, analytics, ML, whatever you want to call it, right? Even in Indian industry, there is a huge acceptability on IoT devices, right? A lot of organizations committing, saying that we are already using IoT, or probably we will use it in a short horizon. So IoT increase has definitely gone up. But there are some other areas that we have discussed in Industry 4.2, which so far have received less implementation. Acceptability always there, but implementation wise little on the lower side. And those techniques are essentially 3D printing, augmented reality. Though there is acceptability, though people see a lot of value in seeing that, but actual implementation in the organizations, actual implementations in the industry have been little limited, right? Little limited. So when the managers were asked, where are the investments going to be, right? Where are the investments in 4.0 going to be? So most of the people seem to have said in a particular survey that in terms of cloud, they have already invested. In terms of cyber security, they have already invested. In terms of robotics, they have already invested. In terms of IIoT, right? In terms of IIoT, the general feeling is it will happen in the next 4 to 5 years. But most of them saying that they are thinking about it, they know the potential for it, but they have not actually implemented that to a great extent. Everybody agrees that it will happen in the next 5 years. I'm talking to you about specific Indian scenario, right? A survey from Indian scenario, right? Other examples like additive manufacturing, 3D printing, and so on, right? Some of them have started implementing, but if you look at it in a typical manufacturing way, I would expect at least the tier 1 organizations, the OEMs, right? OEMs particularly, not even the tier 1 organizations, to implement some of these techniques first and then percolate that down the supply chain, right? Down the value chain. So probably OEMs will be the first one to implement because they have the scale, they have the budgets, right? Implementing autonomous robots, implementing system integration, right? Integrating IIoTs is going to require some amount of money, right? Initially, the capital investments, and those are available with OEMs. So I expect them to implement all these techniques first, and then it will and then the OEMs are going to say that, well, if I want supply chain visibility, all of you also have to put sensors and generate real-time data so that supply chain performances can be tracked, and therefore it will percolate down. Some of the other industries like financial industry, I told you, they are already data savvy. I mean, we had econometric algorithms and algorithmic trading happening already. Those industries are anyway at the forefront. We spoke about pricing optimization, right? Services organizations have been very very agile in implementing some of these pricing algorithms, right? Particularly, we spoke about airline industry, we spoke about hotel industry, dynamic pricing, right? I see dynamic pricing and those kind of algorithms getting implemented in B2C kind of B2C kind of organizations, business to consumer kind of organizations. In the B2B sector, manufacturing, right? Let us look at a tier 2 supplier. Tier 2 supplier supplies only to the tier 1 supplier, right? Those kind of B2B suppliers, they will probably not generate a lot of value from dynamic pricing, but service industries have a huge potential to gain from dynamic pricing, and they are already doing it, right? So that's where I see the growth, right? That's where I see the growth. Some of the other industries where we definitely see the growth, right, are some of the process industries, right? Process industries, we have not spoken about them quite a lot, but we expect the process industry to also become very good in terms of implementation of many of these AI ML techniques, right? That brings us to one more interesting discussion that we should have, which is XaaS, right? XaaS, right? Very soon we are all talking about XaaS, right? X being anything, right? You have heard of SaaS, software as a service, right? Platform as a service, right? Or product as a service. We spoke about it, right? We very briefly spoke about product as a service. For example, if I am a truck fleet operator, the one thing that I'm going to need frequently are tires, right? So I'm going to buy tires, I'm going to run my trucks, and depending on the usage, the trucks are going to the tires are going to wear out, and at some frequency I'm going to change these tires. So instead of buying tires from the tire manufacturers, can I buy tires as service, right? So for the tire manufacturing company, they are selling product as a service. They are not selling tires, they are selling tire service, right? The mileage as a service. So they can guarantee that, well, if you use my tires, I will guarantee that you will have uninterrupted no downtime on the trucks. I will make sure that the tires are replaced optimally depending on the usage. How do I know the usage? How do I know the wear and tear? Probably I have sensors to understand the terrain on which the trucks are used, and therefore I have some predictive modeling, and I can understand the wear and tear of the tires, and I can understand the optimal time to replace the tires. I will know exactly where the truck is, right? I don't have to bring the truck to the garage to change the tires. I can actually take my tires to the truck wherever the truck is, and without having any downtime on the truck. When the truck driver is resting, probably that's the time I can change the tires. All that thing can happen once I have visibility, once I have predictive modeling power, and all of that is now available, right? So essentially, we are going to see this a big way. XaaS is going to happen big way, and it is entirely because of real-time data availability that we are going to have. Anything as a service, right? AAS is as a service. X is anything. X is X, right? X is a random variable. So anything as a service is definitely going to happen. And the main reason for that is going to be AI and ML.